Bismillahirrahmanirrahim. Welcome back to my channel. I'm back with a video, and this video is a little bit different than what was going on in my channel. This video is going to be on cryptography, one of the applications of cryptography, and one of the applications that you can think of cryptography. It pops up in something called TOR browsing. Let's say if you want to surf internet anonymously, you can use TOR browsers, and the way it works like this. Let's say if I am the source, which is located, I'm located, let's say, in US, and I want to go to I have a request for a server which is located somewhere in Russia. So what does this TOR network do? It will take my request and it will not directly send, just like in internet, it will take your request and directly take you through something called your web server using different hops. It will take you through something called onion routers, which are called ORs. And what these routers do, your request will go and will go to an onion router which might be located somewhere in Germany. That request will go to another onion router which might be located somewhere in France, and this will take you to another onion router which might be located somewhere in China. And then after that, your request will go to the original destination. That's the idea behind it. So basically you're trying to mask your IP address using these onion routers. As you know, onions, you can just peel off each layer. So idea is exactly the same thing. In actual TOR circuits, your request will always go through 3 circuits. 1, 2, 3, or 3 nodes. And this entire thing, this connection in red that you're seeing right now, this is called a circuit. I need to make that circuit. Whenever, excuse me, whenever I start my TOR browser, I need to make this circuit first. So we're going to go through this process, how we actually make this circuit. We'll try to understand how this connection is made from A all the way up to E. So in order for you to understand this, so this we are calling this connection, we are calling it a circuit. You got to understand 2 things. You got to understand there is a packet. In the original paper, the author has used a word cell, so I'm going to use something called a control packets, control TOR packets, and control relay packets. So first type of a packet that you will see, that you will start transmitting from my originator, which is source A, the original source, which is going to be onion proxy, is going to transmit to first onion router, is going to be a control packet. That control packet will consist of something called a circuit ID, a command, and a data. The circuit ID will be 2 bytes, command will be 1 byte, and your data is going to be 509 bytes. So the total size of this control TOR packet will be 512 bytes. Then after this control packet, you're going to use something called relay packets. These relay packets are also going to be with 512 bytes. They will also have a circuit ID. They will also have relay, stream ID, digest, length. In the command section, it will also have a command and your data. This command will have different command in it. So for example, for control packet, it might have a command called create, which means to create a connection. Second, it might have, this command can be any value which can be which could be created. And there are so many other values. In our example, or what I want to show you, when we are developing these TOR circuits or these connections, we just only need create and created. There's a list of it. Same thing in your TOR packets. It might have a command called relay extend, relay extended, connected, relay begin. These are some of the command values that can go in. So let's go through this process. And I drew a diagram. I drew a timing diagram. I want to share that with you. And let's just quickly have a look at that. So let me just quickly show you. Okay, so this is what this is going to be. So this is the original guy that is actually sending a request to the first router, first onion router. And then that request will go through another router and then actual website. As I told you before, there will always going to be 3 routers which are going to be involved. In my example, I just did it on 2 routers. But this thing can continue to 3 routers. Now, the first thing is going to be, remember, in your TOR ID, packet ID, you have something called a circuit ID. So in circuit ID, you will have an ID. ID is just going to be some integer value. All right, so in our case, we just left it like ID from A to B. So the first connection that is going from A to this onion router B. All right, so A is the originator and B is going to be this guy. This is going to be C, and this is going to be my original website that I want to go. So this is going to be your A, this is going to be your B, this is going to be your C, and this is the actual destination. So this ID is going to be how long? This ID is going to be 2 bytes long. So this is going to be some integer value. Now, the next thing, if you were to look at it, it will have circuit ID, your control packet. So this is going to be your first control packet that will be sent from your original onion proxy to your router B, onion router, first router. So this is going to be some integer value. This is going to be some command value. So this is going to be a control message. And what are the values of command can be there? So this is ID, A to B. It's going to be an integer value. Now the next thing is going to be a create. So it will have a command that, you know what, create me a connection, first connection. All right. In order for you to create a first connection, you need to have, and what will be in the data packet. If you were to look at this, in this data, this information is going to be there. 2 of the dominant protocols which is being used by TOR browsers are going to be your RSA and your Diffie-Hellman. All right, Diffie-Hellman key exchange method and RSA. So the data of this packet, of your control packets, control TOR packets, will consist of a key, a Diffie-Hellman public key for your user A, which is here, and it will send that its public key to B, which is this first onion router. All right, so what does this data will contain? It will contain a Diffie-Hellman public key parameter which you will send to B, which is going to be your onion router 1, which will be encrypted by its public key, RSA public key of this router, which we are calling it OR1, which is going to be your B. Right, so ID is just going to be some circuit ID, which is going to be integer value. In our for our example, I just use an ID AB. It will have a command called create me a connection, and the data will consist of a Diffie-Hellman public key parameter of your A, the onion proxy, which is this A. It will send this to B, and this whole data will be encrypted using a public key, RSA public key of B. So the only person who can actually unlock this data information is going to be a guy who will have a private key. In our case, is going to be B, onion router 1, which will have a PR, which means a private key. So it will unlock this using a private key, and it will check and see, you know what, this guy has sent me his Diffie-Hellman public key parameter. All right. Now, once B OR1 will receive that data, it will reply. It will reply with something called the same ID address, same circuit ID, and it will send, the command will be now created. This is also going to be a control message. And this, it will send this, it will also send its Diffie-Hellman public key parameter to A, which is onion proxy. Notice I don't need to encrypt it because this is actually the guy who actually initiated it. So I don't need to encrypt it, which it's A's public key. I don't need to. That's why in first I did, but there could be a chance that some other guys will drop in. But here, only this guy will get this message. So I don't need to. After receiving this, what will happen is this. This onion proxy will send its ID again. It will now check, instead of sending a control packet which looks like this, it will send a relay packet. In a command value, it will say, you know what, okay, this is the first onion router. I want you to extend this to another onion router. So that's why you have relay extend command. Now, what does this will contain? This will contain A wants to send its Diffie-Hellman public key parameter to C, which is going to be this. So this is your A, this is B, this is C. So it will have it just like in a first step. We send his public key parameter, Diffie-Hellman public key parameter to B, which is onion router 1. Now in this, when you send a command relay extend, it's saying to B to extend this to another router. In our case, this is going to be OR2 or C. So this will contain Diffie-Hellman key. of A, which will be for C, for onion router 2. This whole thing will be encrypted with C's public key, which is going to be its RSA public key. That's why I have PU, public key C, public key RSA public key of C. And this whole thing will be encrypted by the session key which was generated. If you remember Diffie-Hellman algorithm, you know that once you have your public key parameter, A's public parameter and B's public parameter, based on your public parameter, you will create a session key. If you remember it, you can recall it. I made a video on it. I'll leave a link to it. You can create something called a session key by just sharing your public key parameter using Diffie-Hellman key exchange. You can generate a session key which will be common for both A, onion proxy, and OR1, which is going to be B. So this whole thing will be encrypted. Now, once B will receive this data, B will send this with a different ID now. Once B will receive this data, it will send this data to C, because you have data which is intended for C. Now the circuit ID will change. That circuit ID will be a different number. That circuit ID will be ID BC. Of course, in real term is going to be an integer value. You need to create another circuit or another connection. Now, if you were to look at it, since A and B will have a shared key which was based on Diffie-Hellman algorithm, B will decrypt this. Once B will decrypt this, it will end up with this data, which is actually a Diffie-Hellman public key parameter of A to C, but that was encrypted using a public key of C. So router B will have no chance of decrypting this message, this data message. Why? Because this data message is actually encrypted with C's public key, which was generated through RSA algorithm. Now, upon receiving this, which is C, which is OR2, OR2 will send data to B. You know what? I have created this. I have created this. So it will send its now. What in the data packet will be? The data packet will be Diffie-Hellman C, Diffie-Hellman key, public key for C. That is intended for A. Now, once it receives that data, B will send this data to A, the original originator, which is onion proxy. Now, this message that will be sent by B to A, that will definitely contain the Diffie-Hellman public key parameter of C to A. Also a message called relay extended, that you know what, indeed you told me to create another relay, I have extended that relay. Upon receiving this relay extended message, this will send another command. Now this is going to be a relay command. Why? It will have exactly the same ID, because you are still going to talk to ID from A to B. And you know what? I need to go to that particular website. Now this relay begin will start transmitting. Okay, you know what? Now the real data is going. ID, circuit ID is going to be there. Relay begin is the command, and I want to visit this website. This message will be taken from here to here. Now you got to understand this. Each of these messages that will be generated from here to here, here to here, they all will be encrypted using that session key that we have generated earlier. Why? Because once it's encrypted with KAB, this data packet is encrypted with KAB, only B can decrypt that. Once this message reaches here from B to C, this will be only encrypted using decrypted using KAC, and so on and so forth, because this guy and this guy will have the same session key, and this guy and this guy will have the same session key. B is just working as an intermediate node. Now relay, and then after this message will receive to original web server, now it's just going to be a normal TCP handshake, and this is how the transmission will take place in a TOR browser. So having that said, let's just look at a practical overview of this. Let's open up my TOR browser. Now if you were to look at it, it says configure connection. Just click on configure connection. Alright, and let's just test. You know what? and let's just hit connect. I want to show you. Now, start establishing your connection and actually start connecting. Let's just simply go here. Let's go to google.com, and I want to show you. Just open up your browser, and it's going to start making that circuit that we just described earlier. Start going through this process. Is going to start looking for those 3 routers that it needs to connect to this website, which is going to be google.com. All right. In order for me to look at it, let me just simply go here. Now, let's look at this. Or on your Tor browser, if you were to look at it, this is a Tor circuit which I just described. Just simply go here. Now look at this. This browser, as I told you in Tor browser, your request will will always go through 3 different circuits. So this is my request that will go through 3 different circuits, 3 different nodes, 1, 2, 3, and then the original web server. Now let's look at it. If you go there, my browser, which is A, which is the initiator, which is actually started the control message, it's going to this bridge, then it's going to Germany, then it's going to United States, then it's going to google.com. All right, and this is how this message. So every time you start your Tor browser first, it will take some time to actually establish this connection. You can also go to the properties of your Tor browsers. Just simply go here and go to advanced, I believe, go to settings and go to connections, and you can use, these are different bridges. These are different bridges. You can just remove all the bridges if you want, and then you can select a built-in bridge, and you can use this built-in bridge like this and click OK, and these are your bridges value that you can use to connect them, connect to a different web server. So that's the idea behind it. I hope you understood the technical part of it. How does this RSA and Diffie Hellman is interlinked together to actually make these bridges that we are trying to make in our example. I hope you like the small tutorial on Tor browsers. If you have any questions, leave it in the comment section, and don't forget to like and subscribe to my channel.